friends, now we are in the 10th class of Signal and System Basics. Here the 41st problem is, consider the discrete time system shown in the following figure. This is the figure given where the impulse response of Gz is G0 equal to 0, G1 equal to G2 equal to 1 and rest all G are 0. Means G3, G4 all are 0. Okay. This is the figure given. The system is stable for the range of values of k. There are 4 alternatives given and this question has been asked in GATE 2007. Okay. So here this is the question. So now we can write Gz as let me write G at first. Let me write Gn. Okay. So it is given that Gn is okay. It is given that. So let me write here. Given that Gn equal to nothing but Gn equal to 0 at n equal to 0. So this will be 0 multiplied by delta n, okay, plus 1 multiplied by, okay, G1 and G2 both are 1. So 1 multiplied by delta n minus 1, okay, again 1 multiplied by delta n minus 2, okay, and rest all are 0. So there is no need to write all those things. So we can easily write here, this is delta n minus 1 plus delta n minus 2, okay, delta n minus 2. Let me write here delta n minus 2, okay. Now if we take the Z transform of both the side, then it will come Gz. So taking Z transform, it will be Gz equal to the Z transform of delta n is 1, okay, and if it is delayed by suppose some unit, then Z inverse will come. So it is delayed by 1 unit, so Z to the power minus 1 will be associated with the Z transform of delta n. So it will be Z to the power minus 1, okay. Here the delay is 2 units, so Z to the power minus 2 will be associated with the Z transform of delta n. So here we can write Z to the power minus 1 and the Z transform of delta n is 1, okay, plus Z to the power minus 2 and Z transform of delta n is again 1. So it is Z to the power minus 1 plus Z to the power minus 2, okay. Now we will write the transfer function for this system, okay, the system given in the figure. So the transfer function for this system will be nothing but since it is positive feedback system, so the transfer function, let me write the transfer function of the system given in the figure so transfer function of the system given in the figure is how much? So it is if we denote it by Hz, then it will be nothing but Gz divided by 1 minus k multiplied by Gz. Here minus sign comes because it is a positive feedback system. If it could have negative feedback, then we would have written positive sign here, okay. Now the characteristic equation is 1 minus k multiplied by Gz equal to 0. So we can write here the characteristic equation is nothing but 1 minus k multiplied by Gz, this is equal to 0, okay. So now the question asks about the value of k for the system to be stable, okay. So now we can write here 1 minus k multiplied by gz is nothing but z to the power minus 1 plus z to the power minus 2. Okay, this is equal to 0. Okay, now we can write here, if we multiply it by z to the power 2, then it will become z square minus kz minus k, this equal to 0. Now if we calculate z, the value of z, so z will be nothing but it will be k plus minus under root k square, okay, minus minus 4 multiplied by 1 into minus k, okay, so it will be plus 4k, okay, divided by 2. So it will be like that. Now let us check for which interval the value of z for the system to be stable, for a discrete system to be stable, all the poles must lie within unit circle. Okay, all the poles must lie within unit circle. So we have to check in which interval these the poles, there are two poles because there are two values, one for plus and another for minus. So we have to check whether this value of z, or you can say the value of pole, is lying within unit circle or outside the unit circle. So here it is given that 1 by 2 minus 1 by 2 2. Okay, so we have to check on these points. So if we take 1 or minus 1, okay, so for k equal to 1, z equal to 1 plus minus under root 1 plus 4 divided by 2. So 1 plus 4 itself, 1 plus minus under root 5 divided by 2. Okay, so if we add 1 plus root 5 by 2, then it will definitely come greater than 1, because root 5 itself is greater than 2. Okay, so if we add 1 plus root 5 by 2, then it will be greater than 1. So in this case, the one root is lying outside the unit circle. Okay, so in this case there are two roots, 1 plus root 5 by 2 and another root is 1 minus root 5 by 2. But this root is clearly, we can say here, this root is greater than, okay, this we can say this is greater than 1. Okay, so if this is greater than 1, then obviously it will lie outside the unit circle. So if it lie outside the unit circle, then the system will not be stable for k equal to 1. Okay, so let me check for k equal to minus 1. Okay, so for k equal to minus 1, the value of z will be minus 1 plus minus under root, okay, minus 1, it will be nothing but it will be 1 plus 1 minus 4 divided by 2. Okay, so it is nothing but minus 1 plus minus under root minus 3 by 2. Okay, and this is nothing but this is the square, this is the cubic root of you can say unity, or so we can write here it is minus 1 plus minus j root 3. Okay, let me write it clearly. It will be j root 3 by 2. Okay, and its magnitude will be equal to it. If we find its magnitude, then its magnitude will be equal to 1. Exactly its magnitude will be equal to 1. Okay, so its magnitude is equal to, here its magnitude is equal to 1. So we can write here for this case mod z is equal to 1. Okay, so let me write for other cases here. Let me write here. Okay, now if we check for z equal to 1 by 2. Okay, so for k equal to 1 by 2. So for k equal to 1 by 2, what will be the value of z? So z will be nothing but it will be 0.5, okay, plus minus under root, this will be k square means 0.25, okay, plus 4k. 4k means 2. Okay, so it will be 2 divided by 2. Okay, so it will be nothing but 0.5 plus, okay, it will be nothing but 0.5 plus minus under root 2.25, okay, by 2. So under root 2.25 is nothing but it is 1.5. So it is nothing but 0.5 plus minus 1.5 by 2. Again we can see for plus value the magnitude is 1, the value of z is 1, and for minus value the magnitude is less than 1. Okay, its magnitude is less than 1. So here we can also write mod z is equal to 1 for positive case and less than 1 for we can write here mod z is either less than or equal to 1. Okay, here also. Now let me check for k equal to minus 1 by 2. Okay, so here for k equal to 1, magnitude is one value of z is greater than 1. So this case cannot be possible because one root is lying outside the unit circle. So case number B is not possible. Again case number C is also not possible because here also 1 is there. So one root will lie outside the unit circle. Again now we have to check between case A and case D. Okay, so for case A, one value of the range is between minus 1 to 1 by 2. So for minus 1, the value of z, the magnitude of z is equal to 1, and for 1 by 2, one value of z is you can say here 1 and another value is less than 1, magnitude is less than 1. So we are only left with this 2. We have to check only 2. So if it will satisfy, so let us see what happens for k equal to 2. So for k equal to 2, here let me write for k equal to 2. Okay, the value of z will be equal to 2. So the value of z will be nothing but 2 plus minus under root 4 plus 8 divided by 2. Okay, so it will be 2 plus minus under root 12 by 2. So we can clearly see that 2 plus under root 12 by 2 is greater than 1. Here we can write that the magnitude 2 plus under root 12, okay, by 2, this will be the magnitude of this is greater than 1, and so there is no question of stability because this is greater than 1 means one root of one root is lying beyond the unit circle for k equal to 2. So we are left with only one option. So this option will also be not correct. So we are only left with option number A, and for option number A, if the value of k is lying within -1 to 1 by 2, okay, so the value of k is lying within -1 to 1 by 2, then all the roots will lie within the unit circle. If we take the value of k between -1 to 1 by 2, excluding -1 and 1 by 2, because for -1 it is the value of z is 1, one value of z is 1, and also for 1 by 2, the both values of z are 1. Okay, so if the value of z is lying between -1 to 1 by 2, excluding these two values, -1 and 1 by 2, then the system will be stable, because all the roots of all the characteristic roots, or you can say all the poles of the transfer function Hz are lying within unit circle. Okay, so option number A is correct one. So now the next question is xz equal to 1 minus 3z inverse, yz equal to 1 plus 2z to the power minus 2 are the z transform of two signals xn, yn respectively. A linear time invariant system has impulse response Hn defined by these two signals Hn equal to xn minus 1 convolution yn, where star, this is the symbol of convolution, it is also written here, where star denotes discrete time convolution. Okay, then the output of the system for the input of the here it should be for the input of the input, no, not of the input, it should be for the input. So let us write here for the input, so output of the system for the input delta n minus 1 will be. So here 4 options are given, and this question has been asked in GATE 2007. Okay, so it is given that, let me write, given that the impulse response, okay, it is given that the impulse response, this is impulse response is defined as Hn equal to xn minus 1 convolution yn. So let me write the impulse response, the impulse response of the system is Hn equal to nothing but x n minus 1, let me write here also capital big bracket, okay, convolution yn. So if we take the z transform of impulse response, then it will give the transfer function. So we can write here the transfer function of the system will be Hz equal to z transform of xn minus 1 into convolution will get converted into multiplication into z transform of yn. So the z transform of the transfer function will be the transfer function, or you can say the system function also. So the transfer function, or we can also say system function will be how much? Hz. So Hz is the z transform of Hn, a small hn, and since here xn minus 1, so z transform of the delayed input, since this input xn is delayed by 1 unit, so it will be z inverse xz. Okay, so it will be z inverse xz, where xz is the z transform for xn, which is given here, into this convolution will convert in multiplication into yz. Okay, now if we put the value of xz as 1 minus 3 z to the power minus 1 and yz as 1 plus 2 z to the power minus 2, then it will become z inverse. So we have to multiply here, so it will be 1 plus 2 z to the power minus 2, okay, and here minus 3 z to the power minus 1 minus 6 z to the power minus 3, okay. So if we arrange it and multiply by z to the power minus 1, then it will come how much? So the minus 3 z to the power minus 2, again 1 multiplied by z inverse, so it will be z to the power minus 1, again 2 multiplied by z to the power minus 2, so it will be 2 z to the power minus 3, and again this 6 z to the power minus 3 will get multiplied by z to the power minus 1, so it will be 6 z to the power minus 4. Okay, now it is given that if the input is delta n minus 1, so what will be the output? Now we have calculated the transfer function of the system. So to calculate the output for input delta n minus 1, let us take the output as yz. Okay, so the output when we apply delta n minus 1 as input in Z transform, yz, this will be equal to nothing but sz transfer function multiplied by Z transform of delta n minus 1. So this multiplied by Z transform of delta n minus 1. Okay. Here this is the symbol of Z transform. Don't confuse with this Z and this Z. This is the symbol of Z transform. Let me write here. This is the symbol of Z transform. Okay. Now the Z transform of delta n impulse function, unit impulse function is 1, and since it is a delayed input function and delayed by unit 1, so its Z transform will be Z to the power minus 1. Okay, so now we can write here yz equal to nothing but Z to the power minus 1, which will be the Z transform of delta n minus 1 multiplied by sz. Now if we write the value of sz from the above equation, so it will be Z inverse multiplied by minus 3z to the power minus 2 plus z to the power minus 1. Okay, so 3z to the power minus 2 plus z to the power minus 1 plus 2z to the power minus 3 minus 6 z to the power minus 4. Okay, so if we multiply it, then it will come z to the power minus 2 minus 3 z to the power minus 3, okay, plus 2 z to the power minus 4 minus 6 z to the power minus 5. Okay, now if we take it in you can say discrete domain or time domain, you can say, then it will be yn equal to, now if we take the inverse Z transform, then this will become yn. Okay, or you can say yn like this, yn. So yn will be nothing but it will be, this will be delta n minus 2. Okay, so this will be delta n minus 2 and this will be minus 3 delta n minus 3. Okay, this will be 2 delta n minus 4 and this will be minus 6 delta n minus 5. Okay, now let me see, or we can write here in big bracket also. Okay, like this. So let me see which one is the correct option. So here we can see delta n minus 2, okay, minus 3 delta n minus 3 plus 2 delta n minus 4 plus minus 6 delta n square. So option number B is the correct one. Okay. At the last of the lecture, I would like to share one of the most important thing to you people, that if you like my video, then you must subscribe the video, so that there is no need to search the new video which I upload. The automatic upload will come to you. What you have to do for this? It is very simple. There is a circular logo containing my photo is coming in right of me. You have to just click on that for subscription.